so that we learnt about the values of coating the circuit boards. We didn't know much about making small inverters. 5 million sales, it's all over the world and everybody knows about it. The small things that you've got to get right.
Hello and welcome to the MICROMASTER Museum podcast, a podcast that celebrates a frequency converter sold more than 5 million times globally. I will be talking to people whose lives have been shaped by the MICROMASTER and who have contributed to the success of this landmark converter. My name is Susanne and I'm collecting artifacts for a virtual MICROMASTER museum. Our first exhibition hall is going to be filled with stories and music. An audio space for customers, students, Siemens employees and story lovers where they can explore the world of MICROMASTER. Let's go back in history and see what the world was like when the MICROMASTER was first released. The product was launched in the late 1990s and early 2000. Around the time of product launch, Google had just started making money from advertisements and released its first ever press release, announcing $25 million equity funding. Just a few months later, in 2001, Apple introduced the iPod, a breakthrough MP3 music player. Having covered some of the basics, it's time to hear from Andy, who has known the MICROMASTER from the very beginning. He is a Siemens colleague from Congerton who has seen the MICROMASTER develop from the early product series to the very much loved present-day 440 series. I am especially grateful to Andy, who retired from Siemens a few years ago and who still talks with passion about our products. As you will hear, the dedication to and interest in this product is still very much alive and kicking. Listen out to the brief history of the product series, the challenges along the journey, and how the team had to manage different customer requirements for hardware and software.
Well, it was really quite interesting. The MICROMASTER that you speak of is, in essence, the fourth MICROMASTER that we made, which followed the 6SE20 and the 6SE21. So those were, if you like, the first steps, our first dabble with this small technology. And it was very interesting. We didn't know much about making small inverters, and reliability wasn't our strong point. Anyway, we moved on and we began with the MICROMASTER 1. We moved on then to the MICROMASTER 2 and the 3, all the time learning. And then we came to the MICROMASTER 4, which is the one that we're really interested in, the one that made 5 million sales. It's all over the world and everybody knows about it. But when we were bringing the MICROMASTER 4 into the world, there was a really big pressure on delivery time and a big pressure on price. Those were the two really important things. And then not far behind it was reliability. Those were really three important things that, price, reliability, and this you could split, if you like, into the hardware and the software. From hardware point of view, it had to be the right size, and it had to do what the customer wanted. And from a software point of view, we were still growing from what we were learning from the earlier products. And in the early days of the MICROMASTER 4, we were very reactive. The customer base wasn't as big then as it is now. And we didn't have the modern development techniques that we'll speak about later. So we were very reactive. If we got a good customer that wanted something adding to the features in the inverter, we were very quickly doing these things. We were making software changes. It was really, really interesting. The whole thing was quite dynamic.
As you may remember from our first episode, the first few years after the product launch were years of valuable learning and adjustments. I asked Andy about this, and he confirms that a number of product improvements had to be made. Andy gives examples and talks about a very specific case at a jute factory.
The MicroMaster 4 was, if you like, dragged into existence. It was like a difficult birth, shall we say, and there were consequences. There had to be some modifications made to the hardware. There were some early painful learnings, really, I think, and we had to move. We had to react, which we did. It took time, but where we got to was that we thoroughly investigated anything that failed, be it hardware or software, and it was like an evolution. I don't think we were different to our competitors. I think everybody was learning. There were developments in circuit technology. We had to react to robustness requirements that we didn't know about in the early days. We tested to the standards, the EMC standards, but we soon realized that we had to look beyond that. That just meeting published standards was not sufficient. We had to look about how these products were used in a real world. I think somebody said some time ago that bad news travels about 11 times faster than good. And if let us say, somebody in the ceramics industry had bought our product and it failed, then when they were down at their local club or bar at the weekend talking with their competitors and colleagues, you don't want to buy this drive because we've had problems with it. So then we had to be reactive. We had to investigate. And we were fortunate that there were a passionate group of people in that factory in Congleton that wanted to get to the bottom of things. We got it eventually to a stage where if something went wrong, we could pretty much say, what has the customer done? But it took time to get there. For example, I had to go to India several times so that we learnt about the values of coating the circuit boards to improve the robustness of the inverters. I went to visit a site near to Calcutta where it was a jute factory where they made jute for making sacks and such. And the waste jute, they burnt. So these little fibres burnt and became little carbon strands, finer than a human hair. These went up the chimney, were taken by the wind across the factory, across the roof of the factory, and when the wind was in the right direction, they were taken in by the air intakes of the inverter room. They got into the inverter room, and then inverters are really interesting things because they're a computer and they're a series of high voltage switches. And if these little strands were able to get where there were big volts and bridge over to where there were only supposed to be little volts, there was a bit of a flash and the thing stopped working. And that was a painful exercise where we learnt about the values of coating circuit boards, which we do in the factory today. This is the sort of thing that it was painful, many flights, many dead inverters, much cost. but valuable learning,
Next, Andy talks about customer requirements and illustrates how understanding a customer's application is so important. The various controls and inverter configuration opened up a new world of customer requirements.
The various controls, the way that the I/O functioned on the inverter sort of grew from customer requirements, and it was a little bit peculiar, but people grew to love it. But it was possible to configure things so that the inverter might run the motor backwards. We thought about this, and we ended up putting in a new parameter which you could enable, which basically said, under no circumstances, run backwards. We did this because textile manufacturers that run rotating weaving machines that weave T-shirt fabric, for example, they weave a tube. These machines have maybe 2,000 or 3,000 fancy little needles in them that work perfectly if the machine runs forward. But if it runs backwards, it breaks the needles, and it's a nightmare. So it was possible to configure the inputs such that you could run the thing backwards, but we put a parameter in there that said, under no circumstances go backwards. Another thing that we learned, it's still, I believe it's still in with the dynamic stuff, I think compressor manufacturers, they also have requirements that the damn thing must only go forwards. If it runs backwards, there's a noise comes out of the compressor and all the engineers run for cover, It's not a good thing. So we had to react, I would say. We had to react to requirements, react to what we got from the field, and we had to build a reputation, and that came.
After having learnt about running a motor backwards, let's move forward and hear Andy's thoughts on drives technology and why it is the right thing to switch to dynamics.
Well, technology that was available to users of PLCs and inverters was quite limited when MicroMaster 4 came into fruition. And now we've got all the internet-based, Ethernet-based communications protocols and such like, and we've had to move. We've had to adapt. And there are new development techniques, there are new components, it's time to take the step, and the Dynamics product was the right thing to do. It was good to be able to take what was learnt from MicroMaster 4, all about robustness and cooling and reliability and software reliability. It's almost worse if a product fails intermittently than if it just goes bang, You wouldn't believe the damage you can do with a little inverter if it doesn't do the right thing in a car plant. I always said that, there are three things you don't want to stop. One's a car plant, one's the launch of a ship, and one's a paper mill. Because if your little product causes a problem that messes around with these things, the costs are phenomenal, so it's vital that these products work right. And the big benefit is for the user of maybe 3 or 4 pieces a year. He gets this reliability, he gets this dependability because of the requirements from the big users. And it was painful learning this, but we got there. And that's why your Dynamics inverter is arguably a world leader, and when it's put together with all the other Siemens products.
As mentioned, this podcast is also about the MicroMaster soundtrack. Andy has selected a song that was released in 2000 and may not be familiar to all our listeners. All the same, the tune was selected by Rolling Stones magazine as one of the 100 greatest pop songs of the same year.
music that was knocking about at the time, because it's 20 odd years ago. And I remember a track by a band called Blink 182 it was called All the Small Things. And I thought that was an important play on words, because it's the small things that you've got to get right. But it was, it's something about a relationship too. And it's a relationship between us in the factory and that darn product, So I thought that was a reasonable track, and I like the sound of it too.
What a good choice and closing statement from Andy. Getting the small things right mattered 20 years ago and is just as relevant today. Thank you, Andy, for your time and talking to us about your experiences with the MicroMaster. Your insights and stories are an important contribution to the museum. The details you gave us from the jute factory show just how important it is to know our customers' environment and all the small things in the air. Thank you, Andy, and thank you for listening to episode 2.